In this lecture, we are going to have mainly two topics. We will see that in the first topic, we are going to look into what is the meaning of static longitudinal stability and how an airplane can be set in a static longitudinal stability and what are the criteria for that. In the second topic, we will look into what are the contributions from different component of the longitudinal to the longitudinal stability. And when I say different component, it means I am talking about the wing and tail, because those two are the major contributor to the longitudinal stability. So going forward, we should ask a question that how a balanced trimmed flight behave when it is disturbed in pitch, whether it is going to return back to the trim condition or whether it is going to diverge away and become completely unstable. So to understand this, we have a figure of an airplane over here in the right hand side, which is showing a side view of an airplane. And before having any discussion, we must remember that pitch up moment is a positive moment, which is a clockwise moment, while the pitch down moment is negative moment, which is anti-clockwise. So we have a figure over here of an airplane which is flying at a trimmed condition, which is flying at a trimmed condition with angle of attack alpha e, and all of a sudden there is a gust of wind comes from the left hand side and it disturbs the airplane and changes the angle of attack from alpha e to alpha. So that if the airplane have the tendency to return back to its original trimmed condition, then we would say that this airplane is longitudinally stable. If it doesn't have tendency to return back to its trimmed condition, then we would say that it is a longitudinally unstable situation. So to further understand this, let's consider two design scenarios. So in design 1, we have an airplane flying at a trimmed condition with angle of attack alpha e and moment about center of gravity is 0, because we know that in a trimmed condition there is no moment above the center of gravity. So this moment coefficient is 0. All of a sudden there is a gust of wind come from the left hand side and it disturbs the airplane and increases the angle of attack. In that situation, the airplane creates a negative moment, restoring back to its original trimmed condition. Or if this gust of wind decreases the angle of attack for this airplane, then there is a positive restoring moment is created that bring back the airplane to the trimmed condition. This is the design 1 scenario. In design 2 scenario, our airplane is flying at particular trimmed condition with angle of attack alpha e and moment about center of gravity is 0. When it is disturbed with the gust of wind such that the angle of attack increases, so rather than having the moment, restoring moment, it creates a positive moment that takes it further away from the equilibrium condition or trimmed condition. In another scenario, what can happen is that the gust of wind decreases the angle of attack, and rather than having a restoring moment, there is a negative moment that takes it further away from the equilibrium condition. So in this design scenario, which is our airplane will never return back to the trimmed condition where I was initially flying. So this is very undesirable, and this situation we don't want to have. So design 2 is an unstable situation, while the design 1 is longitudinally a stable situation. So this is what we want and this is what we don't want. So we've seen that which is stable and which is unstable. Now we have here the plot. So this is just showing the same thing that we discussed above. So we have a flight over here that is flying at particular trimmed condition, and we increase the angle of attack, then it creates a negative moment that restore back to the trimmed condition, and if the gust of wind disturb the airplane, decreases the angle of attack, then it creates a positive moment, and that positive moment bring back the airplane to the trim condition. So this is a scenario for the stable situation. So while if we look at this second line plot, which is on right hand side, we have the unstable situation where the if you increase the angle of attack, it is going to have the positive moment. If you increase the angle of attack from the trim condition, which is going to have the positive moment, and it will take away from the trim condition. So to have the longitudinal stability, we establish two necessary criteria, and that is the moment at zero angle of attack must be positive, and the slope for a moment against the angle of attack must be negative to have a longitudinally stable flight. We can have the another scenario also. So here we have the green line, which is showing the balanced and stable flight that we discussed, while the pink line is showing the balanced unstable flight, which we don't want. Other than these two, we can have another scenario where we are seeing that this green dashed line is showing the unbalanced and a stable flight. So unbalanced flight is such a flight which doesn't have any trim situation. So it doesn't have any trim angle of attack. So in this particular flight, there is never going to be any situation when the moment about the center of gravity is going to zero. So this particular curve have the negative slope, but it doesn't have the any trim situation, because this dashed line is never going to cross this x-axis, which is alpha, and hence this for particular flight line there is never going to be any trim situation. So this flight will be never balanced. In the same way, we have another dashed line over here, dashed pink line, which is unbalanced. At the same time, it is unstable. Unbalanced because this dashed flight line is also not going to have any trim situation where the moment is going to be zero, because we are seeing that the moment is all increasing, and it is unstable because it have the positive slope. So now we have established the criteria for having the longitudinal stability, and this green line that we are seeing over here can be expressed in this straight line form, where the first term over here is showing the y-intercept, that is moment at zero angle of attack, and the second term is basically the slope multiplied with the angle of attack. So we've seen that this two variable is deciding factor to have the longitudinal stability. Now with this we understood that what is the meaning of longitudinal stability and what is necessary criteria to have the longitudinal stability.